Welcome back. In the previous episode, we've gained remote code execution on our local machine because we knew how to leverage the buffer overflow vulnerability. Today, it's all about exploiting the remote machine, which is hosted on the CTF URL. Let's get started. If you're interested in learning more about these techniques, if you are interested in pursuing an ethical hacker career, then I encourage you to head over to academy.thehackerish.com. There you will find online courses that you can enroll to and just find a suitable course for you. It should give you a great start. Okay, so we don't need OllyDBg, we don't need Ghidra, or close those windows. And what I'm interested in now is to exploit the remote host, which means generating a new shellcode, because remember, the remote machine is a Linux box, if you recall from our first episode. So we need a shellcode that goes with that. And to find the right payload, we actually need to just retype the same command as before. msfvenom payloads, and instead of Windows, I'm just going to look for Linux. Give it some time to look through the database, and hopefully we should get back some candidates for our reverse shell. It's taking some time. Let's be patient. Hacking is all about being patient. Okay, looks like we have some candidates here, and the one I'm going to go after is, you guessed it, this one. 32-bit architecture, reverse shell TCP stageless for Linux. So let's run msfvenom, payload, this one, lhost. Now, for the local host IP address, it wouldn't be localhost because we're not running it locally, but instead it's going to be our public IP address. So I'm going to use ngrok to open a local port out to the internet for the time of the execution of the attack. You'll find the documentation on how to use it, how to authenticate to it online. It's not really complicated. You just need to sign up, create an account, and get the token. And once you've done that, you can run it with TCP command because we just want to open a TCP socket. And I'm going to listen on port 4444 locally. So this essentially means we're going to expose port 4444 locally to this host name on this port. So to continue msfvenom generation payload, the local host would be this host name. I know it's not going to work, but just to show you a point here. And the local port, you guessed it, would be this one. And once more, we're going to get rid of anything in our shellcode that contains those 3 characters. And we're going to output that into shellcode.bin. It's going to complain because msfvenom doesn't want to use host names. If you know why, just drop me a comment below for those of you who are familiar with how msfvenom works to generate this kind of shellcode. As you can see here, it says address family mismatch. And that's because it doesn't want to use a host name here. That's not a problem for us because we're going to use the corresponding IP address. So using dig command, I can give it a host name and it will output the A record for this host name, and so we can use that here. Okay. So now if everything goes well and if the exploitation works, the remote host will connect back to this public IP on this public port, which in turn will be nothing but localhost on port 4444. So I just need to make sure that I have a netcat listener on port 4444 and wait for the shellcode to be generated. I have a lazy machine this time. It doesn't really want to execute any command, and it's taking too much time. Okay. Cat sc.bin and base64 encoded without new lines. That is a really small shellcode for Linux. Okay, now echo this string and base64 decode it and put it in our shellcode.bin. So in your opinion, what should we change here? So we are already opening the same file sc.bin, so nothing to change here. Offset is the same. The return address for JMP ESP is the same. NOP operation is the same, and shellcode, so nothing here. But we need to change here, instead of localhost, well, it would be CTF whatever host name we had. I don't really remember. Let's go back to the beginning of our challenge, CTF24 rootme.org. We've come a long way from knowing the password or guessing or analyzing the source code to find the password. So hopefully, if everything goes well, we should get back a reverse shell. Let's try it. Enter and connection received on localhost, and if we type ID, we successfully got a remote shell on the remote machine by exploiting the buffer overflow vulnerability. So as you can see, we are the user Puck. So if we list the content of the home directory, there are other users here. One of them is Puck. So in the next video, we're going to leverage this remote shell to get local privilege escalation and get root, and then read the flag /passwd. Until then, stay curious, keep learning, and go find some bugs.